if we take a look at our game here, we're going to be looking at our legal moves. Once we lock in how many stones drop off in the movement origin grid, which if we're in a move type move, we select this to move the stack, we drop 1, we hit enter. Now these are legal moves because they're orthogonal and they're empty. Not that they're empty, but that the stone that's in them isn't a capstone or a standing stone, or it's empty. But look, no other legal moves are true right now, or at least rendering. But once we click on a move, we're now actually rendering legal moves for orthogonal spaces to that one, but as well as our original down here. So these two were originally right, then we clicked on this. This should have been nullified. Then it allows us to either move here or here once we drop another set amount of stones in there. So we'll have to add the drop logic as well, but for now we're just trying to, I guess, render the correct legal moves, which means we also need to lock in a direction and then limit the arithmetic for legal moves depending on a locked in direction. I guess what I wanted to do last time was use a function right here. Once we lock in first movement grid, once we do that, then we need to run a function that will falsify all of our current legal moves. Then we reassign our move locked row, and then later on, depending on our move locked row, it'll highlight the legal moves. But we need to do not only just this logic here, but we need to do slightly different logic once we have a direction locked in. So I'll have to figure that out. So let's work on this function here. Falsify all legal move in our grid. So legal move is a Boolean field within our occupant class. So in our place state, we can write a function much like our reset board function, or much like these functions. And that function is going to be called falsify all occupants legal move. Okay, and it takes in an occupant. Actually, if it took in a table of occupants, that'd be even better. That's okay, we can just run through. We can run through all the occupants anyway, no problem. Basically, we need to we just need to modify the dot occupants. The occupant that gets passed in, its legal move just needs to get falsified. So actually, we can make this not take in anything because we need to run it on all occupants regardless. And we just say for I gets 5, for I gets 1, 5, do, and then a nested for loop. For j gets 1, 5, do. So for a 2x2 array of 5x5, which is our board, we're going to say grid at I, j, which is an occupant, its legal move gets assigned to be false if we run this function. So now that we have this function, we can run it down here when we lock in our first movement grid locked, meaning we've dropped our stones in the movement origin space. We're going to run that function, falsify all occupants legal move, which should turn all of our old legal moves into no longer rendering the highlight, and then we're locking in the new move locked row, new move locked column, and then we're applying the old logic to render those legal moves, to actually assign those legal moves, and then we're checking if our mouse is over it to actually render it. So look, we're gonna drop a stone here. We're gonna lock, see how we have two legal moves from our movement origin grid, that's right. Now if we click this one, if we click this one, I'm hoping this one will cease to render and will actually only render this space, and this space is legal move, and this space is wrong. We just need to update that. But I clicked it. We are no longer rendering the old legal move or the other legal move. We do, however, okay, so see how I actually want our pathway to be lit up where we actually came from. And I know why that's not working. At least our function is working, where we're clearing our occupant's legal move before assigning the new legal moves here, depending on the move locked row. But we need to do, not only do we need to do something different for that, we need to have a way to render our first movement grid locked. So we would need to save two variables, which is a mouse X grid and Y grid it's just the row and column of the 2D array of the grid that we need to be highlighted. And we're actually unhighlighting anything we're not over by design, but we need to add a small caveat of we need to render the highlight of a first movement locked once it's locked, not whether or not we're over it. So maybe I'm thinking out loud here, because it's like instead of rendering the legal move highlight color, the other color, we could do the move locked highlight. So we shift the move locked highlight, because that isn't being changed by our mouse position. So we might be able to get away with that as long as we're okay with that darker color of the highlight on the second stone, unless we want to change it to be a different color. So it's called a move locked highlight. So upon our right here, upon locking in this grid, we're going to actually turn our grid at our current mouse position, the grid under our mouse cursor. We're going to turn that Boolean's, what do we call it? Legal move locked highlight. So we're going to say, hey, dot move locked highlight of that occupant is now true in that space. We'll have to remember to flush this once we're switching players, but oh look, and this is wrong, hold on. This is we need to do it upon hitting enter. First movement grid locked. That means we're clicked on a legal move. guess I'm confused when we hit enter. Yeah, we hit enter to shift our stones in hand locked. Now if our stones in hand locked, then we have the ability to drop. Okay, that's what's confusing me, is we don't have the ability to drop the second one yet. We can drop our stones in hand first, lock that in with an enter, but that doesn't mean we're trying to render our new move locked. What's it called? Move locked highlight. We want to do that upon locking in. Actually, yeah, upon clicking on a first movement grid. So yeah, this is right to add it here. But then, yeah, no, this is right. I guess I'm confused why we would set legal move highlight to be true, because this is just getting overwritten anyway. I mean, I wanted the legal move highlight to be true. That's the line I probably added to get it to render the light green, but since our mouse isn't over it, that just gets flushed. It never gets pressed again because that's only under the mouse press function. I'm going to see now if we lock in that darker green color when we lock in our first movement grid. So drop 1, stones in hand locked. Now when we click on this, I'm hoping it'll turn dark green, and it does. And it renders the next orthogonal spaces as legal moves. But this is not a legal move. We need to have different legal move logic depending on our direction. So okay, we're close, we're close. Yeah, we're close. We just got to go to so yeah, instead of our normal here legal move logic here. See, we're doing these if stones in hand locked portion of the move, meaning the very first movement, you can go in any direction. However, you know, if first movement locked instead, then we want first movement locked legal move logic, which depends on which direction we're going. But I know we're going to want this. If first movement locked. And we should actually probably do else if statements. Don't exactly know why, but it might prevent a bug. Because we would be doing 2 legal moves operations if those were just if statements. Possibly if we weren't triggering these variables right. So yeah, this is the legal move logic for the different periods of the program. And we need to figure out what that logic actually means. Like, what does it mean to lock in a direction? I guess if it's row and then column, right? For our 2D array. Let's look at the numbers here. So I'm going against the columns. It's 1, 2, 3, yeah. So it goes row in the first bracket, first row, second row, third row, and then first row, or first column, second column, third column, fourth column. So it goes row, column, row. How many down? How many over? So in this previous iteration, we were doing some arithmetic logic here, just hard coding in the arrays that are surrounding us. But we need to be able to figure out which direction we lock in by selecting one of this. Yeah, let me just write out. Let's say we've got our middle bracket 3, 3, third row down, third column right. Now, it's a middle stone, so we could hit the stone above it, to the left of it, to the bottom of it, or to the right of it. Now, if we hit the top of it, it would be a 2, 3, because it would be second row, same column. If we hit the one below it, it would be 4, 3, one row down, same column. If we hit the one to the left of it, it's a 3, 2, same row, one column to the left, and then we'd have a 3, 4, which is same row, column to the right. So we have a move locked row currently, and then we have a new mouse Y and mouse X grid. So we can do some simple arithmetic here to decide whether or not it's a space above it, a space to the left of it, right of it, or below of it. So that would be before we reassign our move locked right here. So what we would do is we turn our move locked highlight, so we render that dark green in that space. But what we also need to do is determine whether or not this mouse Y grid, which is the row, and the mouse X grid, which is the column where our mouse is, we need to compare it to our current move locked row. So our first one is our row, which is our Y grid. So we say move locked row. We need to compare it. If our first index, if this grid is bigger, then we have a, if the row is bigger, that means it's a bottom. So if Y is bigger, then our mouse Y, no. Yeah, we need to compare our mouse Y to our movement origin grid. So, yeah. So we can do, I want to do a for loop, not a for loop, an if statement with 4 conditions that tries to lock in where this legal move is, to lock in the direction, because what we can do is how do we do this? We would say, hey, if the mouse Y, which is our row, if our mouse Y grid, if that row is bigger than our current row, and it's a legal move, right? Yeah, we would need to make sure it's a legal move. But we're asking it here. If it's a legal move and we're not first movement grid locked, this is before we lock in first movement. Okay. Yeah, we can put it here. If our mouse Y grid, if our row of our mouse is greater than our old move locked row before we update it, If it's greater than that, then we have bottom lock, bottom direction. I would say let's do up, down, left, and right direction. So down direction, camel case, down direction gets true. Else if our mouse Y grid, if the row of our mouse is smaller than our current move locked row, and that is smaller than the index of our space that is clickable. So it's like the space that's going to become our first movement grid locked. So the first space we move into, once we click that space to move into it, we're going to lock in this direction based on its old origin space and the mouse location in which it was clicked in a legal move. So if our mouse grid is smaller than our locked row, we know then that's a top direction lock-in. And this was the for loop I was talking about. It's not a for loop, it's just for if statements. Else if our mouse X, our mouse X grid, if that is greater than our move locked column, then that's a right movement. And if our mouse X grid is smaller than, it's a left. So there we lock in direction, which we only need to do once, then we can just do the same arithmetic. So like down direction would be an increasing of our move locked row. Top direction would be a decreasing of our move locked row. Right would be an increment of our move locked column. And left direction would be a decrement of our move lock column for our next renders. For locking in our direction for our legal moves, because once you've locked in a direction, your legal moves only go to directly in front of you if the stone isn't inhabited by a capstone or standing stone, and you're not at the edge of the grid. So we've got to initialize these so they're not garbage values from the get-go. So in our booleans up here, we'll give us all these false booleans, or directions. So down, up, left, right. Okay, so we initialize those. Now as soon as we click on a grid that would give us right here, that would give us first movement grid locked true. We are highlighting that square to be that dark green. We are wiping all of our legal moves so that we don't render our old occupied legal moves, and we're instead going to be locking in a direction depending on our mouse position when this is clicked, to lock in a direction from our movement origin, and then we're going to be Then we're going to be resetting our move locked row to our current mouse position. And then we're going to do the rest. Now, we need to assign these legal moves based on I'm trying to think of, we flush legal moves right here. So we would need a similar one if we mouse click. Oh my gosh, it's hard to look at the code. Yeah, basically, I'm going to see if anything crashes real quick. This should just be locking in those direction. We could print up, actually let's do that. Let's print up the direction that we're locking in here. I'm going to turn this line on, and I'm actually going to put in oopsie. Oh God, Jesus, come on. What I'm going to print is right direction. Just going to see if we lock in right. And then we're going to concatenate that with a string of our actual right direction boolean. So that should become true once we lock in the right move on our clicking on a legal move. So right here, we need to select how many stones to drop in our movement origin. We'll render our legal moves. Now if we place this, our right should become true, which it does. It renders it dark, but we don't drop a stone yet. Actually, yeah, we're not supposed to drop a stone. We're just supposed to do that. Then we're supposed to have up and down dropping and picking up of stones at this point. And we're still only rendering legal moves directly to the right and down of it. We haven't implemented the move, the direction locked. Okay, we need to flush this to false too. So we need to flush stones and hand locked so that we don't render the wrong stones, and then we need to implement the right stones, legal moves. This part of this phase of the move. So what I'm gonna do is right here, I'm also gonna toggle our stones and hand locked where we're no longer stones and hand locked. I don't know if that messes up anything. Let me see what else stones and hand locked does. Does our legal moves. Falsifies our legal moves. We don't need to do this just yet. Okay. I think we'll be okay falsifying this. Upon pressing enter here. Actually, not upon pressing enter, upon locking in a new one. So right here. Stones in hand, we're no longer in that phase. So that being false there should now mean we don't render the incorrect legal moves anymore. We don't render any legal moves anymore because we haven't done that logic just yet. But if that switched like I hope it would. So we lock in, now we don't render those other ones. and we're not populating them with legal move either. So next up is just to do the move locked row update based on our, actually we wouldn't render anything at this point. We would need to render how many, we have to decide how many stones to drop. So then once we do that, we can worry about that. But I'll just have those as template holders, I guess. Because it's not really a first movement grid locked if it's first movement stones dropped. Yeah, if first movement stones dropped. Because we still need to drop the stones. It doesn't matter that we've locked in our grid, we need to lock in how many stones we have left to move, whether or not we render a new legal move or not. So let's do that first, but I'm gonna call it a day. We at least fixed a couple of things. If we take a look at our git diff here, we can see we added 4 booleans to lock in direction. We implemented a new falsify all occupants legal move function. We lock in the direction. And then we got placeholders for our next code. All in all, not bad. I just made a horrible spelling mistake over here somewhere in our note. Where is it? Come on. Let me just see what line it's on. Right there, 479. No. Here. Jeez, okay. But yeah, we'll commit for today with the message saying locked in first movement grid move locked highlight. Good push. Okay, I'll see you guys tomorrow. We'll do that. We'll lock in that direction for the new occupant logic once we implement our dropping of stones, which should be very similar to this first one. You can only drop one less than the occupants you have. Actually, yeah, how would we drop? We need to be able to drop our whole stack if we want to. So yeah, we'll actually need to. Okay, so this is going to be hard. Is how do we repopulate our stack order 1 of our mouse stones once we nullify our mouse stones 1 by dropping it in the grid and then picking it up again? We would need to pick up its stack order. So we'll just have to make sure to keep track of that so that we can unnullify dropping all the stones, because in the other one we made it so that you couldn't drop all your stones because we kept running into this bug where it would nullify the stone if you would drop all of your mouse stones. So we'll have to figure a workaround on that.